Hello students, we are going to learn the process of rationalizing the denominator. So the idea is we do not really want to have surds on the denominator and we will try to make it into a whole number. Why is it important to do so? Because if we want to do further process, so for instance adding and subtracting fraction with surds on the denominator, then it will be a bit more tedious process than when the denominator is just a whole number, right? So that's the reason. And it's very simple. We will just multiply the surds with the denominator. So we look at the denominator is root 3, so we will multiply it by root 3 over root 3. So you see that this is not changing the value because root 3 over root 3 is just 1. So the purpose of doing so is then making it into root 3 times root 3 on the denominator, so which is 3. In this case, the surd or the root sign disappears, right? And on the numerator, we will have 2 root 3. So in this case, we have no surds anymore on the denominator. All right, so the next example, we have 2 root 7 on the denominator. So it is not necessary to multiply by 2 root 7 over 2 root 7. We will only need to multiply it by root 7, so the one with surd itself, okay? So then in this case, we will have on the numerator 21 root 7, and as denominator we have 2 times root 7 times root 7, which is 7. And then we realize probably by now that here 21 and 7 we can simplify because 21 is 3 times 7. Okay, so as a final result we have 3 root 7 on the numerator and 2 on the denominator, which is already rationalized. There is no surd anymore on the denominator. So the next example is a little bit more complicated. What happens if there is addition or subtraction on the denominator? So we are going to use the property of difference of two squares. Do you remember when we did algebra, when we have a plus b in the bracket multiplied by a minus b, we will have a squared plus ab minus ab and then minus b squared, and then in that case we only have a squared minus b squared in the end. So now we are going to take this as a helper for us. So what we are going to do is we will multiply this fraction with surd form on the denominator with its opposite like this. So then we have to multiply by 1 minus root 5. Going to erase this part here. So obviously we should not change the value, so we are multiplying it by 1 minus root 5 over 1 minus root 5. So what happens in this case, on the numerator we will have 4 times bracket 1 minus root 5, and on the denominator what happens is we have 1 plus root 5 multiplied by 1 minus root 5. So, and in this case, let's think about the denominator first, right? So we have here 1 times 1, 1 times minus root 5, root 5 times 1, and root 5 times minus root 5. So in which case you will have 1, and then minus root 5 plus root 5, and then minus root 5 times root 5, which is 5. And then you see that these two will cancel out, and you will have 1 minus 5 as a result, so which is negative 4, right? So knowing this, we will just write down the result on the denominator, which gives us 1 minus 5, right? 1 squared minus root 5 squared. Okay, so then on the upper part we have 4 times 1 minus root 5. Okay, so in this case we have 4, 1 minus root 5, and then at the bottom negative 4. And then 4 and 4 we can cancel out. So basically the idea is we have negative 1 at the bottom, or we can just say it's negative 1 minus root 5. So which in this case will give you, the final result will be positive root 5 and then minus 1. Okay, hopefully this makes sense. And yeah, good luck with all the practice in rationalizing denominator with surds.